Hi, I am Dr. Rajshekhar Babu from School of Computer Science and Engineering. I'd like to talk on addressing mode in this session. Normally, addressing mode is a concept confusing the students. There are variety of addressing modes. Students are unable to distinguish between the one addressing mode to the other addressing mode. That is the reason I have taken this topic as today's lecture topic. Let us see that one. What are the points going to be covered as part of this one? If you see that one, introduction I will take. Next, I will show you some analogy and then addressing modes. After that one, some summary about this addressing modes, homework and then references. This is how I have scheduled my lecture minute by minute, and then let us see that one what is the objective of this session. The first objective is to teach the instruction set category based upon addressing mode. There are various ways to categorize the instruction sets, and then based upon the number of operand addresses, based upon the operation being performed, based upon the addressing mode. So in this session, I am going to talk about how do you distinguish, categorize these addressing instructions based upon the addressing mode. That will enable the student to visualize the internal operation of the addressing modes. So these are the materials going to be used as part of this class, and then so let us recap the prerequisites of this session. So number of fields in the 4 address, 3 address, 2 address, 1 address, 0 address instruction is, you know that one, number of addresses plus opcode. So if it is 4 address, it is the 5 fields. 5 fields, 3 addresses, 4 field, 2 addresses, 3 field, and 1 address is 2 field, and 0 address is the 4 field. So define memory access. What do you mean by memory access? The amount of time is required to access the memory to the CPU, we are calling it as a memory access. Then how many memory access needed for 3 addresses? So normally for 3 addresses there are 4 fields. 4 fields we require the 5 memory accesses, and 3 fields we require the other 3. 5 plus 3 totally we require the 8 memory access for the 3 address memory instruction, and then similarly for 4 address instruction we require the 9 memory accesses. And then the list of ways to reduce the number of memory accesses. How do you reduce the number of memory accesses? Take the instructions which doesn't have the more number of fields. That's how it is reducing the number of memory accesses. Let's come into the point here. As I told you that one, the computer instructions are classified or categorized into the different ways based upon the number of address fields, number of operation to be performed, and then addressing mode. So this class I am going to talk about the addressing mode. What is the definition for the addressing mode? The mode of access of effective address is calling as addressing mode. The mode in which it is accessing the address of the operand, calling it as a addressing mode. What is the effective address? The address in which the actual operand is available, we are calling it as a effective address. That means there is the operand. What is the operand? What is the operation? So to perform any operation, we need the operands. For example, if you say 2 plus 3, 2 is the operand, 3 is the operand, plus is the operation. So that these 2 and 3 are there somewhere in the address. That address we are calling it as the effective address. The mode in which accessing that effective address we are calling the addressing mode. There are wide variety of addressing mode. Before explaining all this addressing mode, let me take the analogy and explain in better way. So let me take the analogy of postman. You all know that one. What is the job of postman? Postman job is to dispatch the letters to the various houses. So let us assume that one there are 4 categories, 4 cases of the dispatching of the letters. The first case is letter for himself. So that letter for himself is the first category. So that letter is for himself, so that he doesn't go anywhere, and then he can have that letter with him. That is the first case I have taken. The second case is letter for one of his family member. So he knows that one. That letter is for the one of his family member. He is known that he is well familiar with the address, and then directly dispatch that letter to that family member. That is the second one. The third one, if you take that one, letter for the known addresses, it is not for him, not for his family member, and it is for some address. he is very quite familiar with address, so that happily he will go to that address and then he will dispatch that letter. The fourth one is here, is a letter for the unknown address. When the situation scenario comes like this, a letter for unknown address, normally we will inquire that one, where and how and all those things. That is how this postman is inquiring this gentleman about this address. The gentleman told this postman where is the address and all, and then that's how this postman reaching to this house and then dispatching the address. There are 4 cases I am summarizing here. If you see that one, the first case is letter for himself. The second case is letter for the one of his family. The third case is letter for known house. The fourth case is letter for the unknown house. Now I want to map addressing modes to one of the each one of this one. So what are the mapping? The first one, letter for himself, will be called as the implicit addressing mode. Letter for the himself is calling the letter for the implicit addressing mode. The second one is the letter for the one of his family member is the immediate addressing mode. The third one is the direct addressing mode, letter for the known address, and then letter for the unknown address mapped to the indirect addressing mode. These are the 4 analogies mapped to the 4 addressing mode. So that's what, so that in immediate addressing mode, implicit addressing mode doesn't require any operand or any operand address. So only opcode will be there, it will perform the operation. In the second thing is a known address. That means letter for the known address is mapped to the immediate addressing mode, where the data, the operand is available as a part of the instruction. So the third one is the address for the letter for the known address. It is calling as a direct addressing mode. The direct addressing mode is nothing but it is a known address. So that is directly going to that address and getting the data from that one. That is the direct addressing mode. The fourth one is the address for letter for the unknown address. Letter for the unknown address, the moment you come and then it is unknown. It is somewhere is there. First it is going to the one address, and from there getting the effective address, reaching to the effective address of the operand. So these are the 4 cases mapped here, and then let us see that one by one in detail, the implicit addressing mode. When the moment you see the implicit addressing mode, it has only opcode. Opcode is nothing but operation to be performed. So it doesn't have any address of the operand or the operand itself. That means only operation. So this is the simplest one, the implicitly specified the instruction, and then the example for this one is DEC. The moment you say DEC in operation, so decrement, so doesn't require any operand, doesn't require any address of the operand. Decrement, the moment decrement, so whatever the content is there in the accumulator, that will be decremented by 1 or 2 based upon the architecture. That is what calling it as the addressing mode. What is the advantage of this one? The instructions specify the fixed and unvarying addressing mode. This is the fixed addressing mode, unvarying addressing mode, and then no memory references. So that as I told you that one, as many as memory references are needed, so that it is increasing the time here. So that if there is no memory reference means it reducing the amount of the time required to execute our program. And then what is the disadvantage? Limited computational capability. But it can perform only on the operations on accumulator, so that it doesn't get any values from the outside. So it will be only perform the operation on the registers of the CPU. That is the disadvantage of that one, limited computational capability. And then the second one is the immediate addressing mode. This is the simplest addressing mode, and then data is the part of this addressing mode. That means in the earlier case only opcode is there, it doesn't have any address of the operand or the operand part of that one. In the immediate addressing mode, it is having the 2 part of the instruction. One is the opcode, other part is the operand. So that this is the only operand. If you see here, move #100H R1. What does it mean? So the meaning of this one is the value 100 to be transferred into the R1. And then this is the meaning of this one. That means we are transferring the value. That means there are 2 fields in that in the instruction. One is the opcode, which is the default one. Other one is the data directly available, not from the main memory or some other part of these memories. And then this is of instruction format, opcode and then operand, opcode and operand. So that the next one is the advantage. What is the advantage of that one? Thus mode can be used to perform the operation between the constants. And then the second one is the initialize the values. Suppose you want to initialize the particular register to a particular value, that can be done by making use of this instruction. And it doesn't require the memory access also. But this is better than the earlier one, which is the implicit addressing mode. Implicit addressing mode having the limited computation capability because it doesn't have the any data which is with the, to perform operation. But in this case, we can provide the data directly along with the instruction. The disadvantage with this immediate addressing mode is a limited operand size. What does it mean? Limited operand size. For example, assume that this operand size is around 8-bit, so that it can hold the only 8-bit size of the operand. If at all you are having the operand size is more than 8-bit, it cannot handle that one. That is a basic disadvantage with this one. That is why we want to move to the next addressing mode, that is calling it as a direct addressing mode or the absolute addressing mode. So in this direct addressing mode and absolute addressing mode, which is the data is available as in the main memory, and then the CPU will go there and then get the data from the main memory. Since there is a disadvantage with the immediate addressing mode where the operand size is not fit to that one, and then we are storing into the main memory. So that this is an example. If you see here, this is the opcode size and then effective address. That means this is not an operand, and then this is the effective address. That means the address in which the data is available. So that this is going to be, this is assume that this is a main memory. In this is a main memory. In this main memory, so that this address, this is CPU will go for this one. And then this is how it will get the things here. You see here? So that this is one, and then going there and then getting that thing. So this is the effective address, and then this is the address in which the operand is available, and then going to the main memory and then getting the data. Because this is not compatible for the earlier addressing mode. Now this, because of the reason, and then we store the operand here, the address in which the operand is available, that address is stored here, and instead of having the address directly, the data directly in the as part of instruction, now address is there. So example you see here, move 30 A4 R1. What do you mean that one? 30 A4 is not an operand. This is an address of the operand. So that it will go to the address of that main memory and store, copy it into this R1. This is what direct addressing mode. When you come to the advantage, large operand magnitudes, so it can handle the large operand magnitudes. But what is the disadvantages of this one? So limited address size. Suppose the number of addresses, that means if the size of this field is limited. For example, I have a memory, the last field size is around the 16-bit, whereas this size is 8-bit. But it is not possible to store the 16-bit address here. So that first we have to store this one in the 8-bit address memory location. In that address, there is effective address of the 16-bit address. So that this is a disadvantage with the direct addressing mode, because it is not able to hold the, we can't fit the address size more than this one. So that this is a disadvantage this one. So with this disadvantage, we are moving to the next addressing mode, that is calling it as indirect addressing mode. So as I told you that one, the address field does not have the size of the address to be fit into that one. So that first of all, we have to look into the memory location where that is to be copied into the effective address. In that address, there is the effective address. So let us see that one. Let me show you the with the animation. You see here, this is the main memory, and then this is the opcode, this is the effective address. So I have shown this one within the bracket, so that this is the meaning of this one is nothing but it is not effective address. What is the effective address? The address in which the operand is available. But this is not effective address. So this goes to the one address. It is address of effective address. It is holding the address of effective address. So that what it will do? It will go to the main memory where the effective address is available. From there it will go to it will go to the other part of this one. So this requires the multiple references. If you see that one, what is the advantage of this indirect addressing mode? Large addressing space. So we can avail that large addressing space. Suppose we are having the main memory sizes which is which is very bigger, and then the address which is not fit into the operand address field, and then we have to look into the indirect addressing mode. So that based upon our requirement, based upon the configuration, so we can choose the various addressing modes, and then we can write the effective program. So that the way you will write the effective program, which may reduces the number of memory accesses and then reduces the space and then time also. So these are the four addressing mode, basic addressing mode, where we are confusing one with the other one. I am repeating that one. The first addressing mode is the implicit addressing mode. The second addressing mode is immediate addressing mode. The third one is the direct addressing mode. The fourth one is the indirect addressing mode. These are all related to the main memory. The other two addressing modes are there. Register addressing mode. That means the addressing with the registers. So this is a memory you can see here, and then this opcode, instead of having the either operand or instead of having the address of the effective address, instead of having the address in this field, we are having the address of the registers. So you know that one registers are there within the CPU, registers are there within the CPU, which are very faster in retrieving the information for the computation. Going to the main memory, getting the data takes the time. That is why most of the time we will get the data and keep in the registers during the computation. So that for speed up the operation and speed up the program, and then we are keeping the data into the registers. So that this is a one. This is similar to the direct addressing mode. Instead of direct address of the main memory, we are having the address of the register. We are having the address of the register. That is calling it as the register direct addressing mode. The advantage of this one is no memory reference. No memory reference means no memory cycle is required. No memory cycle required means the delay is cut down here. So that means it can speed up the program if at all you are using the register direct addressing modes more and more. Then what is the disadvantage? Limited, as you know that one, the number of registers. The number of registers available in the CPU is limited. It may be 32 register, it may be 64 register, based upon the architecture. So that you cannot get the data as much as possible into the CPU, because the number of registers are registers which are need to be used effectively and efficiently. So that this is a disadvantage with this register addressing mode. That is why we are going to the another addressing mode is register indirect addressing mode. What does it mean in register indirect addressing mode? The data will be available in the main memory, and then the address will be stored into the registers, and then the effective address, that means the address of the effective address will be stored in the registers, so that it will go to the one of the register, fetch the address in which the operand is available, go into the main memory. What is the advantage with this one? Again, is the indirect addressing mode. If you see indirect addressing mode, in the main memory itself, we are having the two references. First, it has to go to the address of the effective address. From there, it has to go to the operand in which the address is available. So that two main memory accesses are being used there. But when you use the register indirect addressing mode, so one reference to the registers. So this is not counting as part of this one. So this is not using any memory cycle. So that only one memory cycle being used here, that is there in the main memory access. So that if at all you want to cut down the number of memory accesses, so that you can think of the register indirect addressing mode. So this is the advantage against the indirect addressing mode. So that register direct addressing mode is same as to the direct addressing mode. Register indirect addressing mode is similar to the indirect addressing mode. But in the indirect addressing mode, we are using the two memory cycles, whereas direct addressing register indirect addressing mode, we are using the only one memory cycle. And then the advantage with this one is large address space. Disadvantage is extra memory address, extra memory access. That is the advantage. So I am summarizing the addressing modes which are discussed as part of this class. So we have discussed these are the addressing modes. So once again I am summarizing that one. The mode in which accessing the effective address, we are calling it as the addressing mode. What is the meaning of effective address? The address in which the operand is available, we are calling it as the addressing mode. And then the second one is the first implied or implicit addressing mode. This is the first addressing mode where it doesn't require any operand. Directly opcode will be there, and in immediate addressing mode opcode will be there by default, and then associated with that one there is a operand only, not operand address, only operand. The next one is the direct addressing mode. When you go to direct addressing mode, the opcode part will be there and followed by the address of the effective address. Address will be there in that one. And in the next one is the indirect addressing mode. Opcode will be there followed by the address of the effective address, so that it needs the two multiple references. And the register direct addressing mode, where it has the address of the register within the CPU, so that it doesn't require any memory access. And then finally, the last one is the register indirect addressing mode, which is having the address of the effective address in the register and then going to the main memory for getting the operand. These are the these are the 5 addressing modes we had discussion. The homework based upon this one. So what you can do, you can go to there are around 180 plus processors in this universe. So different processors are using the different addressing modes, different configuration, so that you are asked to collect the instruction set of any processor and categorize them based upon the addressing mode. So you go to the Google and then download all these processor instructions, different processor instructions, and then categorize them based upon the addressing mode. And then this is the information for you. And then you can look into that 160 plus processors are there, and then you can choose any one of the processor and then collect the instruction set of those processor and categorize them based upon the instruction set. So this is a textbook. We can chapter 11 is specifying about this content, and then you can look into the chapter 11 and then for getting the more and more information. Thank you. Hi. I am Dr. Rajshekhar Babu, Senior Faculty in School of Computer Science and Engineering. Today, I would like to speak on Introduction to the Compilation and Lexical Analysis phase. So, these are the topics going to be covered as part of this session. The first one is introduction, second one is programming languages categorization, and then various translators, and next one is summary, homework, references. This is a session plan for this session, and then which will addressing the various cognitive skills of the student. The main objective of this session is to provide knowledge on programming languages and also provide some information on classification of programming language, and also to distinguish between compiler and interpreter. So let us see what is the introduction of these programming languages. Programming languages, before discussing the programming languages, let us see that one, the broad classification of languages. So languages broadly categorized into the 2 categories. One is natural languages, second one is programming languages. Natural languages are being used to communication between the human beings, and then programming languages are being used to communication with the machines by human beings. So we are not going to discuss more on the natural languages because it is a part of natural language processing course. So that we are going to discuss more on the programming languages. These programming languages further divided into the 2 categories, and then that is a high level language, second one is a low level languages. So these low level languages further divided into the 2 categories. So first one is called as assembly language, second one is a machine language. So let us discuss about why do these 2 languages, I mean machine language and then assembly language, brought under the category of the low level languages. As we know that one, machine languages are in the representation of zeros and ones. Since there is a difficulty in remembering the binary equivalent of the instructions and then addresses of these instructions, we move to the assembly language. Assembly language is in the form of mnemonics. It is easy to understand. For example, if there is addition operation, simply we can remember the addition operation by add, subtraction operation by sub, division operation by div, and so on, like that. But still, my question is, why do we bring these 2 things under the category of the low level languages? The reason is these 2 languages are machine dependent languages. That means it will vary from the machine to machine. So if you are familiar with the one machine language and one processor, when you go to the other processor, again you need to learn what is the binary equivalent of a particular instruction, and then you have to learn all those things. This is a basic disadvantage with this low level language. Similarly, this assembly language also like that only. This is also machine dependent language. When you are familiar with the one processor machine assembly language, again you have to learn for the new processor assembly language. That is why these two languages brought under the category of the low level languages. So generally machine understands only machine languages, which is in the form of zeros and ones, that is calling as a binary language. But as I told you that one, it is very difficult to remember, and then it is very difficult to keep track of the address of these instructions. Because of the reason we move to the assembly language. So when you move to the assembly language, the machine will not understand that one assembly language. So that we need something which is translating from the assembly language to the machine language, because machine understands only machine language. For our convenience, for our easiness, we are using this assembly language, so that we need a translator which translates from the assembly language into the machine language. That translator, that is nothing but the assembler. Similarly, when you come back to the high level language, the other broad category under this programming language, high level language. High level language is much convenient than the assembly language. As I told you that one, the disadvantage with the assembly language is it may be easy to understand, easy to remember assembly language, but it is varying from the machine to machine. It is a machine dependent. So when you are familiar with the one machine, and then you have to learn the assembly language of other machine when you are using the other machine. So that this made us difficult to remember, difficult to learn many programming languages, many assembly languages. That's why we moved to the high level language. High level language is unique one. So irrespective of the processor, irrespective of the machine, one language is same for all the processors. That is what the high level language. So that high level languages are very easily manageable and easily to understand and easily to write it. What is the problem with this one? Again, the problem is the machine cannot understand the high level language. As I told you that one, the machine understands only machine language. It cannot understand the assembly language. It cannot understand the high level language. We need a translator to translate from the assembly language to machine language, that is assembler. Similarly, we need a translator to translate from the high level language to the machine language. There are two types of translators again. One is the compiler, second one is the interpreter. This is about a broad categorization of the various languages, natural languages, programming language further divided into the high level language and then low level language. So low level languages, high level languages. Low level language, example for low level languages, the processor assembly languages. So there are many processors are there, languages which are being used for this process are the low level language. High level languages such as C, C++, Java, all these things are the high level languages. So the thing is here, you see here, this woman want to speak to the machine. So she is the one asking that one, hello computer. Then computer is talking to this woman, hello Grace. So how is it possible? How can make it possible? That means by making use of the translators. So that we need a translator to talk to the machines. So human beings want to talk to the machine means we need the translators. There are three different types of translators. We can call it as assembler, compiler and interpreter. So before going to discuss about that one, this assembler, compiler and interpreter, we must know that one, how to process a file, how to compile a file, what is the compilation process. So that this is what we need to know before that one. So assume that one, this is a source file, and then this is where we are writing a program in this form, and then these are the various source files are there. These source files are passing to the compiler. So compiler is generating the object file which is an incomplete file. This compiler is generating the object file, which is a raw file, which is the object file. So that in this object file, all these library routines are as it is. I mean in the form of raw form. So that this object file need to be connected to the linker and loader. So where you connect to the linker and loader, the linker links to the runtime library. So in this runtime library, there are runtime routines are there. The raw form of the library routines will be substituted by the runtime routines from this runtime library, and then that's how the linker will helping us to link with the runtime library for this library functions. And then further is the loader. What is happening with the loader? Loader will load the program into the RAM. That means before loading that one, it will estimate that one how much memory is required for a particular program, how many variables are there, how many subroutines are there, how much memory is required. By looking into its header file, it will estimate that one amount of memory required for a particular program, and then it will allocate that much of memory, and then finally it will execute the exe file. So this is so happened for the production of this execution file. So first it will take the source file. The source files are passing to the compiler. Compiler is producing the object file. The object file is a raw binary code in which the library functions are in the raw form. So that these library routines, library functions are available, routines are available in the runtime library. So the linker will link to the runtime library, and then finally the loader will estimate the amount of memory required for this file, and then it will allocate the memory, and finally the executable will be generated. So let us see that one. What is the compiler? So the compiler is a software. It is not a hardware. It is a software, and then which translate one language into the other language. The language which is to be translated, we are calling it as a source language or source program. The language which is to be which is translated, we are calling it target program or the target language. So this is about the compiler. So that this is a source language. The language which is to be translated, we are calling it as a source language. The language which is translated into the language, we are calling it maybe it is object code or the target language. Example for the source language is high level language. Target language is object code. So what is the interpreter? Let us see that one in detail. The interpreter before going to the interpreter. Let us see that one compiler. So compiler, this is the source language, and then compiler, and then finally we are getting the target language. Let us see that one in detail, how the compiler is operating, and then what are the phases in the compiler and all those things. If you see that one, the compiler, the source program is given to the compiler generates the target program. And for the target program, we are giving the input and producing the output. So that these are the two phases are there. So this target program is nothing but the obj file, which is in which all these library functions are in the raw form. So for this target program, we are giving the input, and then further this target program is linking to the linker by linker, and then loader loading all these functions, and then finally getting the proper output for this particular input. See, the interpreter, it's different from the compiler, and then the source program and then input, both are giving together and then to get the output. So this is the difference between the compiler and interpreter. So in the compiler, first we will give the source program, we will get the target program. For that target program, we will give the input, and then we will get the output. In the interpreter, it's not like that. So that we have to give the source program as well as the input both together to this interpreter. At any point of time, if there is any error in this source program, and then it halts at that point. So as long as you will not correct that point, so it will not move further. That is a disadvantage with the interpreter. Compiler is not like that. It compiles the whole program, and then if there is an error, and then also it will compile, and then it will inform to the user what are the errors are there in their program and
all. Once you create the target program, and then you can compile, you can execute any number of time by giving the various inputs. But in this interpreter is not like that. If you have written even a error-free program, and then we need to again compile and execute again and again this with this interpreter. That is a major difference between the compiler and interpreter. Let us see that one, the basic definition, the basic differences between this compiler and interpreter. So compiler translates whole program at a time, whereas interpreter translates line by line. Input source code and outputs the object code as the compiler, and then inputs program source code and then executes directly. And then compiler saves the object file. There is a facility of the saving the OBJ file here. There is no facility of saving the OBJ file, because of the reason both of them has to go together, like the source code as well as the input both together, so that there is no question of saving the object file. Because of this reason, even if you have written the error-free program, you need to compile and execute again and again. That means both the phases are happening for every statement. But in the case of compiler, the compilation process will be happened for whole program and then followed by the execution process. Whereas in this interpreter, so one for every statement, the compilation process, execution process will be taking place one after other one. Resulting object code is executed by software, and resulting object code can be executed by the hardware. C is the most purely compiler oriented. Lisp is the most purely interpreter oriented. This is a very important important differences between the compiler and the interpreter. Many times, many places, you may be asked that one, what is the difference between compiler and interpreter? So obviously we will tell that one, compiler compiles whole program, interpreter interprets the line by line. But you can add furthermore, by telling that one, compiler there is a facility of saving the OBJ file. In the interpreter there is no facility of saving the OBJ file. So that compiler C is a compiler oriented language, and then Lisp is a interpreter oriented language. By telling these things, definitely we can impress the people. So this finally I am coming to the summary here. As per this, in this session I had discussed about classification of the languages, and then various programming languages such as low-level languages, in which assembly language we have discussed and machine language we have discussed. High-level language also we have discussed as part of this one. Compilation process also has discussed as part of this one. Finally, we have discussed about the differences between the compiler and interpreter. So as part of homework, you can look into that one. At least 10 programming languages for assembly language, high-level languages, which are compiler oriented. Some of them interpreter oriented languages list, and then you know that one, and then 3 compiler and interpreters, and then specify the source language and target language. These are the homeworks which will help you to learn more and more about the differences between the compiler and interpreter. This is the textbook, and then these are the questions.
Hi, I am Dr. Rajshekhar Babu, Senior Faculty in School of Computer Science and Engineering. This session I would like to talk on structure of a compiler. Let us see that one topics to be covered in this session. The first point is introduction of the compilers, and then structure of a compiler. What is front end, what is back end, analysis, synthesis, phase versus pause, and then as usual summary, homework, references will be with this one will be ended. So this is the session plan, and then what is the objective of this session? To provide knowledge and structure of compiler, to distinguish between front end, back end, and compiler analysis, synthesis phase of the compiler, pass versus pace. These are the various points going to be discussed as part of this one. So what is as I told you that one compiler is composed of several phases. What is the reason? It is composed to the multiple phases. So each performing the one specific task. So the compiler process, the compilation process. In the last session, I had discussed about that how to produce a executable file as part of the compilation process. So as part of this one, so if you see that one, the compilation process, and then there are multiple tasks are being performed in the translating from the one language to the other languages. So if there is an error,
at any point, then we need to check from the starting point to the end point of the compilation process. Instead of doing that one, if you divide this compilation process into the multiple tasks, multiple phases, and then we can identify that one what kind of error it is, and then it is occurred into which phase, and then how to fix that error. These are the points going to be helping us in the compilation process very easily. So that is why this compilation process divided into the multiple phases logically. So the job of compiler is monumental, and then it is formulating into the various streams and tokens and all those things. When you see the compilation process from top to bottom, there are multiple phases are there. Let us see that one. The structure of a compiler. The first phase is the lexical analysis phase. The second phase is the syntax analysis phase, and then the third phase is the semantic analysis phase. The fourth one is the intermediate code generation. The fifth one is the code optimization. The sixth one is the code generation. These are the 6 phases of the compiler. So the present day, the compilation process divided into the 6 phases. If you look back, olden days books and all, you may not find the 6 phases, you may find only the 5 phases. So the lexical analysis phase, syntax analysis phase, directly going to the intermediate code generation, code optimization and code generation. There is no syntax analysis phase. The syntax analysis, part of syntax analysis phase was with the semantic analysis phase is with the syntax analysis phase, and part of semantic analysis phase with the intermediate code generation. Later on, the compiler pioneers identified that one, that it is mandatory, it is needed, very much needed to separate the semantic analysis phase from the syntax analysis phase from the intermediate code generation. That's how the new phase came into the picture and it formed 6 phases. Now lexical analysis phase, syntax analysis phase, semantic analysis phase, intermediate code generation, code optimization, code generation. These are the 6 phases of the compiler. My question is, how can we make only 6 phases? Why not 10 phases? Why not 15 phases? What is the definition for the phase? That means here in the compilation process it involves a lot of tasks, so that the logical cohesive operation combined together called as a single phase. That means the similar kind of operation, the similar kind of task, so that combined as a phase, that is what we are calling it as a phase. And then for every phase there will be a definite input and definite output. The output of the one phase will be given to the other phase as a input. So that is why we can divide the operations in the comparison process definitely can be divided into the 6 modules, 6 phases. That's how the form into the 6 phases. That's why we can't make it as a 10 phases and then 15 phases. This is the reason why compilation process can be divided into the only 6 phases. Let us see that one by one, these things. Before going to tell you that one, all these phases are connected to the symbol table and then error handler. So that the symbol table is just like a database where it stores all the information about the source program, and then its structure, its meaning, and then additional information. Everything will be stored in the symbol table. And in error handler, what is the need of error handler? Suppose if there is an error in the compilation process, immediately if it is halts there, then that will not be called as a compiler, it will be called as an interpreter. We need to it needs to be skip that error and then move on to the next statement till the end of the source program. So to handle that kind of errors, to handle the error subroutines, all those things will be made available as part of the error handler, so that all these phases will be connected again to the error handler. Now lexical analysis phase. What is the lexical analysis phase here? And then when you go to the lexical analysis phase, like when you are reading a new language, what do you do first? We will get familiarized with the alphabet. Once you get familiarized with the alphabet, we start learning the small words. So the once you learn the small words, and then if you form the sentence by using the grammar rules, once you form the sentences, you will look for the validity of sentence, whether the sentence is valid or not. Syntactically may be correct, semantically may be wrong. So that this is how we will learn the new language. Same way, this compilation process also will be happening here. Lexical analysis phase. In the lexical analysis phase, it reads the source program character by character and forming into the primitive units. Primitive units means it is a meaningful form words. So primitive units called as a tokens. Tokens are different types. Tokens may be the identifiers. What do you mean by identifier? So it can be similar to the variables in our C programming. C programming we will call it as variables, but in the compiler technology we will call it as identifiers. And then tokens may be the keywords. So we are reserving the couple of words for compilation purpose, that is calling as the keywords. And then tokens may be the operators. So we are using the various arithmetic operators and logical operators. This will be also part of that one. And also tokens may be the something like that, what you call it as constants, numbers. So that these are the four categories. So for the first one is the first one is variables. That is nothing but the identifiers. The second one is the keywords. The third one is the numbers. The fourth one is the operators. This is the functionality of the lexical analysis. Lexical analysis phase reads the source program character by character and forms the primitive units called as the tokens. And also not only forming the tokens, and they also recognize the what type of token it is. And also in addition to this functionality, it also eliminates the new lines, white spaces, comment lines, and so on. And also it eliminates the comment lines and all those things. This is also functionality of the lexical analysis phase. So that the input to the lexical analysis phase is source program, output from the lexical analysis phase is tokenized code. The tokenized code will be given to the syntax analysis phase. What is the functionality of the syntax analysis phase? Syntax analysis phase determines the structure of a program by using the syntactic rules, and then finally it is analyzing the code by grammar, by constructing the trees. We are calling it as the parse trees or the syntax trees. The input to the syntax analysis phase is tokenized code, and then passing that output of the syntax analysis phase is syntax trees, which are passing to the semantic analysis phase. Semantic analysis phase checks for the semantic errors and also add the extra piece of information. What kind of semantic errors it will check? Suppose if you are trying to divide a 0 with some integer, and then you may lead to the infinity. You are trying to perform the operation between the floating point, array variable with the function variable. It lead to the kind of error. So all these things will be identified. All these errors will be identified the semantic analysis phase. In addition to that one, it will add the extra piece of information. What extra piece of information will be added? So it will be added like what kind of token it is, whether it is integer or the real or the character, and also if it is array variable, what is the scope of that array variable, what is the lower bound, what is the upper bound, if it is a function, what is its scope, how many variables are there. All these details will be added. The extra piece of information will be added to this one. So the input to the syntax analysis, semantic analysis phase is syntax trees, and then it will add the extra piece of information to the syntax analysis syntax tree, and finally the output of that one you will call as the decorated tree or the annotated tree. So the decorated tree, annotated tree will be passing to the intermediate code generation. The intermediate code will be dividing the entire code into the in the form of 3 address code. So that if you take any instruction, it must have the 3 addresses. One is the result operand, and then 2 source operand. Or else it less than 2, and then one is the source, result operand, other one is the source operand. So that for copy operations, if you take that one, only 2 operands will be there. If you take any binary operations, you will take the 3 operands will be there. One is the source reference, and then 2 source reference, one is the result reference. So that the whole code will be divided into the fixed instructions and passing into the code optimization. Code optimization will perform the code optimization technique. There are a wide variety of code optimization techniques. It will perform the code optimization technique technique, so that it will perform the code optimization technique which are machine independent. So it doesn't take into the consideration of whether what is the size of the machine, what configuration of the machine and all those things, but it will take the only machine independent and independent optimization techniques such as dead code elimination. Sometimes we will write a code like that if x is equal to 0 and then 1000 lines of the code, so that x is always again you are writing that one x equal to x value is defined as 0 and then it is always false, the code which is coming under this control statement will never be executed, it is calling as a dead code. So that like that there are many codes are there, all those codes will be optimized here and eliminated, finally to optimize and passing into the code generation phase generating the code to the various machines. That means it will consider what type of machine it is going to be generated, how much memory is there, how many address buses are there, what is data bus width, all these details will be taken into the consideration and then generating the code. This is about a complete structure of a compiler, and then let us see that one. In this compilation, this compiler phases, the first 4 phases we are calling it as a front end, the next last 2 phases we are calling it as a back end. What is the reason first 4 phases we are calling it as a front end? Because of the reason the first 4 phases are adding the information to the symbol table, last 2 phases are using the information from the symbol table. So as I told you that one, symbol table is a book, is a database, data structure which keep hold of the source program, source information, and then entire this information will be stored here. And then when you come to this one, code optimization, code generation will be using the information or the data from the symbol table and then doing this one. So this is about the front end and back end. And then analysis phase and synthesis phase. First 3 phases we are calling it analysis phase, last 3 phases we are calling it as a synthesis phase. So that the entire part is divided to the analysis phase and the synthesis phase. Now we are going to discuss about the pass and phase. So as I already defined, I told you the definition for the phase, the logical causative operation combined together we are calling it as a phase, and the combination of such a phases we are calling it as a pass. For example, I have a program of 1 MB, but I have a memory of only 500 KB. But how is it possible to run the 1 MB file on the 500 KB? Because it isn't possible. So what I'll do here, I divide the entire program into the 2 chunks, and then I load the first chunk into the 500 MB, and then I load the second chunk into the next subsequently, and then that means I made it to the first 500 MB, and then the output of the first pass will be supplied to the second pass, and I made it as this one. So that is what difference between the pass and phase. Pass is a portion of one or more phases are combined into a module. Phase is a logical causative operation that takes input of the one representation, produces output in the other representation. We are calling this one. So these are the various differences between the pass and phase. Finally, coming to the summary of this one, and then introduction, and then we have discussed in this session introduction of the compiler. That means what is the reason the compilation process need to be divided into the 6 phases, and then what is the phase and pass also discussed, and then what are the various phases of the compiler, and then what is symbol table, what is the error handler. So what are the phases we are calling it as a front end, what are the phases we are calling it as a back end, and then analysis phase, synthesis phase, and then finally we have discussed about the phase and pass differences. Finally coming to the point here, and then you can also see that one, various compilers and then its phases. Finally, this textbook is referred for this concept.